Hello students, welcome to Engineers Academy. Kindly subscribe my channel if you haven't subscribed my channel yet. Now let's solve this problem 386. In this problem we are given that the shaft, lever and handle are welded together and constitute a single rigid body. So their combined mass is 28 kg with mass center at G, right? So this is the shaft and this is the handle and this is the lever, right? So they are welded together and their mass is 28 kg, so their weight will be acting at this point G and it will be acting vertically downward, right? So this is 274.68. This is 28 multiplied by 9.81. And it is further said that the assembly is mounted in bearings AB and rotation is prevented by link CD, right? So here we have this link CD. So let's say that there is a tension in this link CD, right? So let's say that this is the tension T, let's say. So we are required to determine the forces exerted on the shaft by bearing AB while 30 Newton meter couple is applied to the handle as shown, right? So we have a couple here, this is 30 Newton meter, and we are required to find these reactions, this AX, AY, BX and BY reactions at this point A and B, and there is no reaction in the Z direction, right? Since the motion of the shaft is not restricted along this Z axis, right? So we will have two reactions at point A and point B respectively. Now first we will represent this T force as a vector, right? So we can write that this is T vector and this T vector will be equal to T magnitude into the unit vector, and the unit vector will be from C to B, and we can write that this will be T, and this unit vector will be CB vector divided by CB magnitude. And as we can see that this T force is two-dimensional, right? It has two components, right? So now this is T and we can find this CB vector, right? So how to find this CB vector? So we will travel 600 mm distance in the Y direction and then we will travel 450 mm distance in the X direction, right? So in the X direction we will travel 450 mm in the positive X direction, so 450 divided by 1000, so that is 0.45 meters, 0.45 meters in the I direction, and 600 divided by 1000 is 0.6 meters in the negative Y direction, right? So we will write minus 0.6 J, and then we will find the magnitude of this vector, so that is this is the magnitude. So when we solve this magnitude, so this magnitude is 0.75, right? So we can write that this is 0.75 magnitude, and now we can write this T vector. So this is T magnitude multiplied by, and this 0.45 divided by 0.75 is 0.6 I, and this 0.6 divided by 0.75 is minus this 0.8 J, right? So this is our T vector. Now we can write this W as a vector as well, right? So we will write W, so that W is equal to minus 274.68, and that is acting in the negative I direction. Now to find the magnitude of this T vector, what we can do is that we can find the summation of moment about the AB axis is equals to 0, right? Or we can find the moment about the Z axis is equal to 0, right? So as we can see that this AB is the axis of the shaft, right? So as we can see that this AX and the reactions at A and the reactions at B are intersecting this axis, so we can eliminate these unknowns from our equation, right? So then we will be only left with this T vector and this weight vector, right? So and this T vector is producing the moment about this AB axis and this weight is producing the moment about this AB axis, and this couple is given, right? So this couple is in the positive Z direction. If we curl our right hand fingers in this direction, so the thumb will point out in the positive Z direction, right? So this couple is also about the Z axis. So now to find this moment about AB, we will use the vector analysis. So we can write that we will define the moment arm and we will use the scalar triple product, right? So the moment about AB means that we are finding the moment about the z-axis along the z-axis, right? So we will write k unit vector dot product with r moment arm cross t vector, right? So we will define the moment arm for t vector from a b axis, right? So let's say that the moment arm for t is EC, right? This is point E and this is point C, right? So this will be the moment arm for this t vector. Moment arm can be any vector from any point on the axis to the any point on the line of action of the force, right? So this is the definition of that moment arm. So we can define any moment arm for any given vector, right? So this is REC cross T. We will write plus, then again K, and we will write the dot product, and then this weight, right? So the moment arm for the weight could be, let's say that here is the origin, right? So let's say that here we have origin. So for the weight, the moment arm vector will be, let's say, ROG cross weight, and then we will add this moment, since this given couple is about the z-axis and this is in the positive z-axis. So we will write plus, and this is 30, and this will be equal to 0. So now we will apply the vector triple product, right? So this is k, so we will write the I and j component of this vector is 0, right? So we will write 0, 0, and this is 1, and REC. So REC vector is, to reach that point C from E, we need to travel 0.6 meters along the positive y direction, right? So I will write 0.6, and the I component of this REC vector is 0, and the k component of this REC moment arm is 0, right? And now we will write this t. So we can write this t. So I will write the magnitude t outside, and this is 0.6 I and minus 0.8 j, and this is 0. Similarly, I will write plus, and again the k vector is 0, 0, 1. ROG. So this is ROG. So again, to reach that point G from O, we need to travel 220 mm distance, or 0.22 meters, right, in the positive y direction. So I will write plus 0.22, and the I component is 0 and the k component is 0. And similarly, the weight is acting in the negative I direction. So I will write minus 274.68, and this will be 0 and 0, right? So this will be equal to 0. Since these both of these elements are 0, so we can find the determinant by using only this element, right? So this is 0 into minus 0.8, and this will be minus 0.6 into 0.6, so this will be 0.6 square, and this t, so we will multiply this with t plus, and now again we can find like this. So this is 0 into 0, and this is minus into minus plus, right? And then so we can write that this is 0.22 into 274.68, and this will be equal to 0. Here we have also plus 30, right? So I will write plus 30, and this is equal to 0, and similarly we have plus 30 equal to 0. So when we solve this, so the magnitude of that t vector is equal to 251.19 newtons. Now to find the reactions at A and B, what I will do is that I will find the summation of moment at point B equals to 0, right? So now we will define again the moment arm for this t vector, right? So since all the forces are producing the moment about this point B, right? this reaction at A is also producing the moment, weight is also producing the moment at point B, and this T is also producing the moment at point B. So let's say that the moment arm for that T vector is RBC cross T vector, and then we will write plus, and then we can write RBA cross A vector. This reaction is A vector, and we can represent that A vector is AXI plus AYJ, right? And similarly we will write plus, and the moment arm for this weight would be RBG, right? So from B to G, RBG cross that weight vector, and this will be equal to 0, right? Now we will find all these cross products, right? So let me write them in determinant form. So RBC vector, so we need to travel 0.6 meters in the y direction. So I will let me write I, J and K. So this will be 0.6 in the positive y direction, and then in the negative z we need to travel 0.6. This is 300 plus 200, right? So this distance we need to travel, this distance, right? So 300 plus 200 is 500, so this is 0.5 in the negative z direction, right? So I will write 0.5, and there is no need to travel in the I direction, right? So this will be 0. And now we will write that T. So again I can write that T, this is 0.6 I, so I will write 0.6 and minus 0.8, and this is 0, and we can write that magnitude outside, right? So this is 251.19, and similarly we will write plus RBA, so the vector from B to A. So we can find that vector I, J and K. So from B to A, we need to travel 0.6 meters in the negative z direction, right? So I will write 0.6 minus and 0 and 0, and A vector is AX, AY, and this is 0. Similarly I will write plus RBG, right? So what is RBG? So from B to G, first we need to travel 0.3 meters in the negative z. So I will write minus 0.3, and then we need to travel 0.22 in the positive y direction, right? So I will write 0.22, and this will be 0. And W, right? So W is 274.68, which is acting in the negative I, right? So this will be 0 and 0. This is plus, right? Now I will write, I will follow this method, right? So let me write this again. So 0, 0.6, 0.6 and minus 0.8, right? So this will be equal to, so this will be I into 0.6 into 0. So this is 0. 0.5 into 0.6, so I will write minus 0.5 into 0.6 into J, and then K into 0, so this is 0, right? And then the negative diagonals, right? So this is 0.6 into 0.6, 0.6 into 0.6, so this is 0.6 square, and this is negative, right? So I will write 0.6 square, and this is multiplied with K, right? And then this minus, this is negative diagonal, right? So minus into minus, plus, plus into minus, minus. So minus 0.8 into 0.5, and this is into I, right? And similarly 0 into 0 into 0, so this is J, right? So 0J. So we get this from this determinant, and this every element will be multiplied with this 251.19, right? So we will write 251.19. So this will be I into 0, right? So this is 0. Then J into minus 0.6. So I will write minus 0.6 AX into J. K0 into AY, so 0. Then negative diagonal, so this is 0. and this is minus into minus, so this is plus 0.6 AYI and 0, right? And then we can write it IJ, so this will be 0, 0.22 and minus 274.68 and 0. So again the positive diagonals, so this is 0, this is minus 0.3 into minus 274.68 into J, and this is 0, right? And then the negative diagonals, so this is minus into minus plus, so plus 274.68 into 0.22, and this is K, and similarly this is 0 and this is 0 as well, right? Now we will combine all the I, J and K components, right? So let's combine the I components, right? So here is, we can see that this is one I term, so this is 251.19, so we will write minus 0.8 into 0.5 into 251.19, and then here is one another I term, so we will write plus 0.6 AY, and there is no I term in this, right? So this will be equal to 0. Then we will combine the J terms, right? So J terms, right? So here is the J term, this is minus 0.5 into 0.6 into 251.19, and then we have this one another J term, so this is minus 0.6 AX, and then this one, right? So this is minus into minus plus, so we will write 0.3 into 274.68, and this will be equal to 0, right? So this will give us AY and this will give us AX. So when we solve this equation, so then AX equals to 11.745 newtons, right? And when we solve this equation, so AY comes out to be 167.46 newtons, right? So now we know AY and AX reactions. Now to find the reactions BX and BY, so we can apply the summation of forces along X equals to 0, right? So we can write that the BX is acting in the positive X direction, so I will write BX, then we will write AX, so AX is 11.745, and then in the X direction we have this W force which is acting in the negative X, so I will write minus 274.68, and then this T has one component in the I direction, right? And that component is 251.19 into 0.6, right? So we will write that is plus 251.19 into 0.6 equals to 0. So this will give us this BX reaction. And now if we apply another equilibrium condition, that is the summation of forces along Y equals to 0, so we can write that this will be BY and then plus this AY, so AY is again known, which is 167.46, and then there is one another component of this T which is acting in the negative Y, right? So that component is 251.19 into minus 0.8, right? So we will write minus 251.19 into 0.8, and this will be equal to 0. Now when we solve this equation, so Bx is 112.22 Newton and By is 33.49 Newton. So the resultant reaction at point B will be equal to Bx square plus By square under the root. So we can write that this is 112.22 square plus 33.49 squared. We will take the square root, and similarly the resultant reaction at point A will be Ax square. So Ax is 11.745 squared plus Ay, which is 167.46 squared. So the reaction at A is 167.87 newtons and the reaction at point B at bearing B is 117.11 Newton. So this is the solution of this particular problem. Kindly subscribe my channel if you people like me, want me to solve and continue such more problem solving.